Hey, this is OXDF. We're doing Advent of Code 2016, Day 23, Safe Cracking, Revival of Code 2023. Let's take a look at the challenge. There's a bunch of story here. We're in the Assembunny's office trying to crack into his safe. It really comes down to we have the same computer we had in Day 12, except there's an additional instruction called toggles. And toggles is kind of weird because what it's going to do is it's going to find instructions. So toggle X means go X instructions away, so it could be positive or minus. So if it's positive 2, go 2 instructions forward, and then change it. So if it's a 1 argument instruction, it becomes inc unless it's already inc, and then it becomes dec. If it's a 2 argument instruction, it becomes jump non-zero unless it's already jump non-zero, and then it becomes copy. The arguments don't change. If I'm supposed to try to toggle something outside of the program, then just nothing happens. If toggling produces an invalid instruction, like copy 1, 2, then it just skip it. If you try to toggle itself, then it's going to change into it toggles a 1 instruction thing, so it's going to become inc, and then you move on. You don't actually run that inc. You just keep keep going. They give us an example program here, which we'll definitely want to grab, and you start with register A of 7. And then the final value is 3. So if I start with register 7 of my register A equals 7 on my puzzle input, what's the value that comes out? So let's go give it a shot. We're going to go back here and grab my day 12 computer object. We have a nice class here, so we'll just grab that. In fact, let's just grab the whole thing here through solve. We're in day 23, right? Start. I got to do my Genday script here to pull the input and give me some stubs. I've got a video that goes into detail about it. If we can grab the computer here into day 23, and we can basically replace all of that with this. So we've got the computer. Let's comment out computer 2 because we don't know anything about that yet. We'll set solution 2 equals none. So now we can run. What else are we going to do? We are going to initialize. We'll do comp.reg. In case you didn't watch my video on that, basically I've got a default dict that I call reg. So I can then, if my register is A, I go to reg A, and it starts at 0, and I can put numbers in it. So we're going to say reg sub A equal to 7, because that was the requirement of the challenge. And then we run the computer, and we need to get the value for A. Perfect. Okay. So this is all good, except for we are now missing, let's see, from collections import default dict. We are missing our new instruction. And before we do that, let's go ahead and write the test for this as well. So we will go ahead and use this. We don't need all of this. We need test part 1. We take example. We call, going to get computer equals aoc.computer on example. And then we are going to say comp.reg A equals 7. We will comp.run, and we will assert that comp.reg A equals 3. Boom. Okay, so we're good there. We've got a test. We need to add, running this now is just going to crash because we're going to get, I guess technically there's no default case here, so it's just going to be a mess. We need to put the toggle instruction in. So we can come down here and pretty easily do case TGL like this. So we got our toggle instruction. It's going to have a single thing, so it'll be T1 because we've broken this into tokens based on spaces. T1, so let's see. We'll do self.get value T1, and that way if it's a register or a value, it returns. That's what our get value function is from the previous one. Basically just checks if it's an int. If not, it turns as a reg. And let's see, what are we going to do? We're going to get a target. Let's call it target equals self.ip plus that. So that should give us what the new instruction we're targeting is. And so now we can say t equals self.lines target dot split I wonder if we should not use T again. I don't think we're not going to use, we should be fine. Yeah, we've got everything we need off of it, so we're just going to TT, I guess we'll call it TT just to be safe. So now we can say match on len TT. So if case of 2, it says, I better pull the instructions back up. If for 2 becomes ink, unless it's ink, it becomes deck. So if TT sub 0 equals ink, TT sub 0 equals deck, else, I wonder if I can do this in like, this is gonna take a lot of space. Can we do TT sub 0 equals ink if TT sub 0 equals, does this work? Let's see. Ink else ink. That looks weird, just very weird to me. Let's see. X equals 5. So if I say deck if X equals 5, else ink. That works. Is that okay? That looks like it's gonna work. So we can do that. There's our case 2. Okay, if we have a 3 long instruction, which means we have 2 arguments, we have to do the same check here. So in this case, the default is jump non-zero, but it could also become copy if it's jump non-zero. So TT sub 0 equals CPY if TT sub 0 equals jump non-zero, else jump non-zero. Now we can say self.lines sub target equal to base.join TT. And so the other thing we have to think about here is like, what if we get, if target is not, if target is longer than self.lines, we want to fail. So we can do this all in a try. In fact, we can just put all of this in a try. And then if we accept index error. So if we hit an index error where like basically we can't reach self.lines of target, because that's the only place we're really doing an index, and we will just pass. Basically, we'll do nothing. If we try to read outside the thing, we do nothing. So that's one of our error handling cases, and we handle it pretty easily. The other thing we have to think about is what happens if, it says, if it doesn't make sense to copy 2 into 1. Because of the way I'm using a default dict, it's going to still go ahead and get the value. So in this case, if I do copy 2, 1, it's going to get the value 2 here, and it's going to copy it into the register of int value 1. Which as long as I don't try to read out of the register of int value 1 later, it's not going to cause me any issues. So I might just let it go and not worry about it. Which I can't ever try to read out of int value 1 because whenever I pass to get value, I guess do I ever try to self.reg? I do like ink here. So I guess if later there's some risk there, we're gonna try it. If we run into bugs, we might have to go back and reassess. Let's see if our we will run our PyTest here. I've got a video showing how to set VSCode up so you can run PyTest straight this way. Let's run it and see what happens. File not found error. It would help if we create our example. Let's do that. So here is the test. Example.txt. Paste that in, save F5, pass the test. All right, we are working. Let's come back to day 23, change this to Python current file and hit F5. We get a number, 11640. Sweet. Part 2. I'm going to read this. I'll come back in a second. Okay, so our code doesn't work, and now we need to actually initialize to 12 instead of 7. And then there's all these hints here about how the prototype computer begins to overheat. You wonder what's taking so long, whether the lack of a more powerful instruction than add 1 has anything to do with it. Don't run these usually multiply. So, and multiply is like there's going to be something with our code that we can't just run this brute force. So let's go set this up. We don't get any kind of test here. So there's nothing we can really test. I guess we'll just go in. I guess our test can be that part 1 still needs to succeed as we change it. So that in that sense, it's going to work. We'll come in here. We'll uncomment this. We don't need to set. So we're going to set reg a to 12. We're going to run, and we're going to get back reg a. Okay, so that all looks good. We'll just run this for the sake of it. In fact, we'll run it outside of VS Code just so we can be sure. Python day 23 like this. Yeah, okay. It's hanging. It's taking a minute, and just given the hint, it's pretty clear we need to not. Okay, let's kill this. I'm gonna run this now. I'm gonna run this again in here. So what I want to try to get a feel for is like, where is it getting stuck? It's been running for a minute. If I hit pause here, where are we in the stack? We're in a module. Let's come up. Ooh, I don't know. Let's see. Hit pause. Let's see, step. Here we go. Okay, so right now we are at self is 5. Let's see if I can split this over. Split right. Let me split down. So you're not under my face. Oh, I changed it. There we go. Okay, so we don't want example though. We want the real thing. Whoa, I don't know what I did there. We will close that, and we will view to here. Perfect. Okay, so we're at 5. Copy BC. Let's let it run again. And it's going through tons of things here. So let's see what we got. Come back here. We can do a step to populate our variables over here, and we're at 5 again on that copy. Let it run for a little while. Stop again. Okay, we're down in the jump non-zero. Where are we? IP of 4. Copy A 0 to A. Keep running. The self is 7. So we're always right in here. Let's take a look at this code and figure out what's going on. So we're going to copy A to B. We're going to decrement B. We're going to copy A to D. We're going to copy 0 into A. We copy B into C. So that's the original A value in C. We're going to add 1 to A and subtract 1 from C. And then if C is non-zero, we're going to go up 2, which is in K. So basically, this little loop right here, 6, 7, 8, is basically going to say A plus equals C. And then C becomes 0. Okay, so this little loop is going to happen a bunch of times. A becomes C, C equals 0. And we're going to dec D, and we're going to jump by 5. 1, 2, 3, 4, 5. Okay, so we're going to reload C with B again. And we're going to do the whole thing again. We're going to do that D times. Okay, so this effectively, right here, is D times B. A plus equals B. A plus equals B times D. And that's the multiplication they're talking about, right? So let's see if we can pull this off into its own thing. I'm going to write another function. Def process mult block self. If we don't need to return anything. So what we're going to do here is we're going to look for we're going to call this, let's see, pass right now. Actually, we're going to turn a bool. What we're going to do is, we're at the very top here, after we get our before we even get our tokens, we'll say if process self.process mult block. If we process this as a big block, then we're just going to continue and loop around. Otherwise, we'll continue the rest of the thing. So basically, now we need to check if this is a block. We're going to do it and return true. Otherwise, we return false. How are we going to get that? I guess we need to say, I'm going to say, let's pull block equals self.lines self.ip colon self.ip plus, let's see, so if we want to catch, if we're 5, or let's see, 0, 1, 2, 3, 4, let's just say 5, 6, 7, 8, 9, so plus 6. So we're going to get those things. We will, I guess let's revert this back to kind of like what it used to be. So we'll do a join around that. So now we've got a single string of those things. And now we can do a regex. Let's import re, because we can match basically to see what this looks like. And we can capture all the stuff that we need to compare. I'm going to go to regex101.com, my favorite. We're going to grab all of this, paste that in here. So now what we need, can we paste it in here too? Yeah. Let's make this, whoa, eating up. Okay. I think I'm having a recording while running heavy JavaScript issues here. I'll probably pause this for just a second and get this cleaned up. Okay. Doesn't seem like Regex 101 wants to stick with my, well, I've got recording going, but I think I can get this overview going. Basically, I've got this string, and it's going to look for copy, then some value. It could have a negative sign optionally. It has one or more word characters. The same thing, new line, ink, the same thing. Now, then I'm looking back to make sure this matches this, this matches this. So that's a backgraph number 2. And so I'm using backgraphs to basically match on this whole string. So we can grab all of this. Copy here. I'm going to go ahead and just close this because it's eating so much. Leave page. Hopefully that frees up any junk there. We can come down here and we can say mult block re equals re.compile like this. We put that in there, wrap text so we can see it. And that should give us a hit. That'll tell us, do we match this block? It doesn't mean that it has to be a C, but it does mean that this thing has to be the same as this and this. This has to be the same as this, etc. So we can say if, I guess we want to go ahead and say, we have our block. We can say if mult block, I guess we do self dot mult block re dot match, because that will start from the start. Block. Next, we're going to say if not that, return false. Now, what we can do is we can go ahead and say args equals self.mult. And I am applying this regex twice, but I feel like most of the time we're going to just fail here, and that'll be a lot quicker. Now we can do findall on block, and that'll give us all the args. So that'll pull out these different pieces, right? And so what do we need to do if we actually have this thing? Well, we need to say register A is going to, I say A, but it's really whatever this is. So the third, 0, 1, 2, args 2, so we can do that, self.reg args 2, that's that register, plus equals self.get value, and it's going to be B, which is this first one, so args 0 times self.get value of args 1, 2, 0, 1, 2, 3, 4. 4. That decrement there, yeah, 4. Args 4. See if we mess that up. So now we've got that. We also want to go ahead, I guess we'll go ahead and do self.reg, because C and D, which in this case are args 1 and 4, also get set to 0 over the course of this, so we better make sure we do that. args1 equals 0, self.reg args4 equals 0. And now we want to, we've just done that whole loop from here to here. So we want to go 1, 2, 3, 4, 5, 6. We want to move the instruction pointer plus equals 6. And then return true. Perfect. So if this function works, which we've got lots of room for typos, when I get to the top here, I will quickly check and see if the block matches the pattern I'm looking for. If it does, it's going to process it all there and jump forward 6. When it returns true, it'll just continue back up and start the loop again. If it does not, it'll process as before. So let's run this again, and F5 now. And let's see, we got some things we don't like. List index is out of range. What is args? Args2. Let's see. Args2. Findall is going to return each instance it matches, it's going to return an object, and that object is going to be the tuple. So we want to just make sure we get this one here, and now we'll have just the tuple. Let's run that again. Get an answer. That was super fast. We'll see if that was actually it. Awesome. That was a fun one. I like that one a lot. Thanks for hanging out with me today. I will talk to you next time.